So this is a simultaneous equation with three letters. Now I'm going to label them A, B, and C. Now we can see that C only has X and Z's combined. So if I use A and B together and get rid of the Z's, I could, sorry, not get rid of the Z's, get rid of the Y's, I could have two equations with X and Z in them. So what I'm going to do is 3y and 2y can both form 6y under the correct operation. So I'm going to multiply equation A by 2 and then equation B by minus 3. And you should see that I'll get plus 6y and minus 6y. And this should make this come out nicely. So I'll multiply the top equation by 2 and I get 4x plus 6y minus 2z equals minus 8. Multiply the bottom equation by minus 3. And then you should get minus 42. Then add downwards. I'm going to get minus 5x minus 8z equals minus 50. Then I'm going to combine that with this equation here, which is your x minus 3z equals minus 13. To get rid of the 5x, I'm going to multiply this whole equation by 5. So I'm going to multiply c by 5. And when I multiply equation c by 5, I'm going to get 5x minus 15z equals, what's it, minus 65. Going to add these together, and I'm going to get minus 23z equals minus 115. Then I'm going to divide in by minus 23. So z equals minus 115 divided by 23. And z minus 23, that is, z will equal 5. Then I'm going to input that back into this equation up here. So it's going to be x minus 3 times 5, which is x minus 15 equals minus 13. X equals minus 13 plus 15, and x therefore will equal 2. And finally, I'm going to have to figure out what y is. So I'm going to use this equation here. 3x plus 2y plus 2z equals 14. And what we'll do is we're going to do x is 2, so 3 times 2 is 6. Z is 5, so 2 times 5 is 10. That equals 14. So it's going to be 16 on the left, and when you move it to the right, it's minus 16. So I'm going to get 2y equals minus 16. I said, sorry, 14 minus 16, which is minus 2. And then I'm going to get y equals minus 1. Now, the next question is you're solving an inequality, and please remember that x cannot be minus 2. Now, you don't square both sides because you don't know. I'll give you a classic example. Minus 3 is bigger than, is smaller than 2. And if I square both sides, what can happen is I'll get 9 is smaller than 4, which is not true. So I don't know whether to reverse the sign or not. It's only when two numbers are positive to begin with. Like 5 is bigger than 3. If I square both sides, it stays the same direction. So no, I'm not allowed to square both sides here. So the technique, which is a pretty standard technique, is you always get the denominator on the bottom, the x plus 2, and you multiply it by x plus 2 squared on both sides. With inequalities, you're allowed to multiply both sides by the same number, and it should maintain its positioning. The x plus 2's cancel with each other, because one's on top, one's on the bottom. And we're just going to multiply this out. So it's going to be 3 times, what's it, x plus 2 multiplied by another x plus 2, which is x squared plus 4x plus 4. And then on this side, it's going to be 2x squared plus 4x minus 3x minus 6. Then we're going to get 2x squared plus 1x minus 6 on one side. And on the other side, it's going to be 3x squared plus 12x plus 12. Bring it all to one side. I'm going to get 0. I'm going to get 3x squared minus 2x squared, which is 1x squared. I'm going to get 12x, take 1x, which is 11x. And then finally, I'm going to get 12 plus 6, which is 18. Now, in the same way that 8 is bigger than 6, I can reverse that around and say 6 is smaller than 8. So what I'm going to do is I'm going to reverse this around. So I'm going to say that it's 1x squared plus 11x plus 18 less than or equal to 0. Now, the way we used to do these back in the day was this is a u-shaped function. And what we're going to do is we're going to determine where it hits the axis. Okay? So where does it hit the axis is what we really want to know. So I'm going to factorize and solve this. I'm going to get x plus 2 and x plus 9 equals 0. I'm going to get x equals minus 2 and x equals minus 9. And what you'll see by that is that our graph would actually hit on both sides. It'll hit twice in the negative x zone. So basically that'd be minus 2 and that'd be minus 9. The next thing we always check out in these curves is the sign. We want to be smaller than 0. This implies that our y value wants to be smaller than or equal to 0, which implies that we're using this region here. Okay, so this implies our answer is minus 9 is smaller than all these x values, and all these x values are smaller than or equal to minus 2. But there is one problem. At the very beginning of the question, it says x cannot be equal to minus 2. So then we go down to the very bottom and we just rub out this part here and we're done. And this is 2018.